All right, so we're going to continue to solve equations in assignment number 7, except this time they're going to have rational exponents. We're also going to be introduced to the idea of extraneous solutions that could come out of an equation that has square roots involved in it. So let's go ahead and get started with this. We're going to do 7 total problems here together. The first one looks like this. Let's start by just getting rid of the 3 here first. Then we can talk about what we're going to do with the 3/4. We can divide both sides by 3, and then that's going to leave us with x minus 2 to the 3/4 power is equal to 24 divided by 3 is 8. But then we want to get rid of taking x minus 2 to the 3/4 power. Well, if I take this whole side and raise it to the 4/3 power, what that does is it takes a power to a power. And if you remember, when we take a power to a power, we multiply the two powers. And so 3/4 times 4/3, the 3's will cancel and the 4's will cancel, and I'm just going to have x minus 2. But if I take this side to the 4/3 power, that means I'm also going to take this side to the 4/3 power. And so I have to know what 8 to the 4/3 power is. Well, that's the same thing as the cube root of 8 to the 4th. Well, the cube root of 8 is simply 2, and 2 to the 4th power is 16. And so that's x minus 2 equals 16, and if I add 2 to both sides, I will get that x is 18. It might be a good idea to plug 18 in just to make sure that that's what we get. We get 24 when we plug that in, and I'm pretty sure that we do 18 minus 2 is 16. I'm going to take 16 to the 3/4 power. The 4th root of 16 is 2, 2 to the 3rd then is 8, and 3 times 8 is 24. So let's continue with this idea. So we have x is 18. So same idea, nothing to get rid of originally here for number 2. I'm just going to take this entire power here, or this entire side here, and raise it to the 3/2 power. And so I'm going to raise this to the 3/2 power. And so 2/3 times 3/2, those all cancel each other out, and I'll have x plus 5 equals, now here's where we have to be careful, because the index is even. If I take the square root of 4, that's going to be plus or minus 2. And then if I cube that, positive 2 cubed is 8, and negative 2 cubed is negative 8. So I'm going to have two different answers here. X plus 5 is equal to 8, or x plus 5 is equal to negative 8. And if I subtract 5 from both sides, I will have that x is either equal to 8 minus 5, which is 3, or negative 8 minus 5, which is negative 13. And both of those numbers work. We can plug a 3 in, and we can plug a negative 13 in, and I'm going to get a 4 both times. And so you really have to watch when there is an index here that is an even number, that you will get two different answers. We didn't have to worry about that on the last problem because the index here was an odd number, and when I have an odd numbered index, I'm just going to get one cube root, not the possibility of 2. And so sometimes we're going to have one answer, and sometimes we're going to have two answers. Let's move on. Take a look at number 3. What I'm going to do on this to make it a little bit easier on myself is I'm going to move this entire expression to the other side of the equation. So that means on the left I'm going to have 3x plus 2 to the 1/2 power. That's going to equal, if I add this to the other side, that's going to equal 2x plus 7 to the 1/2 power. Since they're both to the 1/2 power, I'm going to take both sides and square both sides. That'll get rid of these exponents and these exponents, which is just going to leave me with 3x plus 2 equals 2x plus 7. And if I get the x's together, I could subtract 2x from both sides. That'll get rid of this. If I subtract 2x from this side, I'll just have x plus 2 is equal to 7. And if I subtract 2 from both sides, then x will be 5. All right, and so we get x equals 5. Let's go ahead and move on to number 4. Now here's a situation that we haven't had. It's a square root equation, but we have both x's inside the radical and an x outside of the radical. And so this means there is a possibility that we could get an extraneous solution when we finish this one up. And so let's go ahead and see if we can solve this equation, we're going to have to get rid of the 5 first. I'm going to add 5 to both sides. So I'll have the square root of 3x plus 13 equals x plus 5. And then to get rid of the square root, I'm going to square this side, and I'm going to square this side. And so when I square the side with the radical in it, the left-hand side, I'll just have 3x plus 13. And when I square this side, I'm going to have to multiply x plus 5 times itself. And so that means I'm going to have x squared plus 5x plus another 5x, which is plus 10x, plus 25. And so now I want to get everything on one side of the equation so it's equal to 0. I'm going to do that by moving everything to the right-hand side. So over here I'll have 0. Over here to the right I'm going to have an x squared, but then I'm going to have 10x minus this 3x, which is 7x, and 25 minus this 13, which is 12. And so now we should know 5 different ways to solve this equation. It's a quadratic equation. We can use the quadratic formula, but maybe it's one that we can factor. If I have x times x, that gives me x squared, and I want something that multiplies together to give me 12 that adds together to be a positive 7, and that's going to be a positive 4 and a positive 3, and that equals 0. And so then one of these factors must be equal to 0. Either x plus 4 is 0, which means x is equal to negative 4, or x plus 3 is 0, which means x is equal to negative 3. And because I had an x both inside and outside of the radical in my original question, it is a possibility that one of these is an extraneous solution. And so what I want to do first is check the negative 4 to make sure that this side does equal negative 4. If I take 3 times negative 4, that's negative 12. Negative 12 plus 13 is 1. The square root of 1 is 1, and 1 minus 5 is negative 4. So negative 4 does work. Let's try negative 3. I want it to be equal to negative 3 this time. 3 times negative 3 is negative 9. Negative 9 plus 13 is 4. The square root of 4 is 2. And 2 minus 5 is negative 3. So this one, they both work. And it's possible that they can both work. It's possible that only one works. It's possible that both of them would be extraneous. So you really need to check both of them when you solve these equations. Let's try a different question here. Let's just start. It looks like a simple question. Square root of x plus 6 is equal to x. But you can see there's an x outside of the radical sign and an x inside the radical sign. That means there's a possibility that we could have an extraneous solution. I'm going to start by squaring both sides. If I do that, then on the left-hand side, I'll just have x plus 6 equals, on the right-hand side, x squared. And what I'm going to do is get everything on the right-hand side of the equation. So it's going to be x squared. I would subtract the x. That's a minus x. And then I would subtract the 6. And so I'm going to see if I can factor this. I know that x times x gives me x squared. I know if I have a negative 3 and a positive 2, that gives me a negative 6, and negative 3x and a positive 2x does give me a negative x in the middle, and this is equal to 0. So my two possible solutions are x equals 3 and x equals negative 2. So let's check both of these and make sure that they both work. If I try a 3 in here, 3 plus 6 is 9, and the square root of 9 is 3. So this one does work. But if I plug in a negative 2, negative 2 plus 6 is 4. The square root of 4 is positive 2. But if I plug the negative 2 into the right-hand side, that's negative 2. Those are not equal to each other, which means this is an extraneous solution. And so I'm just going to cross it off. I can put down that it's extraneous. It is not a solution. The only solution here that works is x equals 3. Let's move on and try one that might be a little bit more challenging. Here we have one where we're going to have to get this 3 on the right-hand side first. I would have the square root of 5x minus 1 equals x minus 3. And I'm going to square both sides. So on the left-hand side, I'll just have 5x minus 1. And on the right-hand side, if I square that, I'm going to multiply x minus 3 times x minus 3. That's going to give me x squared minus 6x plus 9. And so I want to get everything on one side of the equation. So if I make this side equal to 0, on the right I'll have x squared. But if I subtract 5x from both sides, it's going to be minus 11x. If I add 1 to both sides, it's going to be plus 10. Hoping again I can factor this. X times x does give me x squared. And if I go negative 10 and negative 1, they multiply together to give me positive 10. But then they add up to be negative 11 equals 0. Which means one of my possible solutions is 10. The other possible solution is 1. Let's just try both of these and see if they both work. If I plug in a 10 here, I want this side to be equal to 10. So 5 times 10 is 50. 50 minus 1 is 49. The square root of 49 is 7. And 7 plus 3 is 10. So this one does work. If I try plugging in a 1, this time I'd want the left-hand side to be equal to 1. 5 times 1 is 5, and 5 minus 1 is 4. The square root of 4 is 2. 2 plus 3, though, is 5, and I want it to be equal to 1. So this right here is an extraneous solution. It doesn't work, and my only solution is that x is 10. So these are the kind of questions that you're going to have on your homework. If you really would like to have an extra challenge, we can go through number 7 together. Here I have 3 radical signs, 3 square roots. So what I'm going to do is square both sides. And so if I square the left-hand side, I'm going to have to FOIL. It's going to be the square root of x plus 1 plus the square root of 2x times itself. So I'm going to have to FOIL that by the square root of x plus 1 plus the square root of 2x. And on the right-hand side, if I square that, I'm just going to get 5x plus 3. And so I'm going to go ahead and FOIL these equations. I'm going to multiply these two together. The square root of x plus 1 times the square root of x plus 1 is just x plus 1. Then when I multiply the square root of x plus 1 times 2x, I'm going to have 2x times x, which is, this is the square root still, it's 2x squared, plus 2x times 1 is 2x. Then when I multiply my inside terms together, I'm going to have the square root of 2x times x is 2x squared, and 2x times 1 is 2x. Then if I multiply my last two terms together, the square root of 2x times the square root of 2x is simply just 2x. And that equals 5x plus 3. So what I'm going to do then is I'm going to add these two things together. That's going to give me 2 times the square root of 2x squared plus 2x. That's going to equal, if I get rid of all of these things and put them on the other side, I have an x plus a 2x, that's 3x. And if I subtract 3x from both sides, 5x minus 3x is 2x. Then I have this plus 1, and so if I subtract 1 from both sides, that's going to give me plus 2. So then I want to get rid of the 2 here on the outside. I'm going to divide everything by 2. If I divide this side by 2, those 2's will cancel. And I have the square root of 2x squared plus 2x is going to equal, if I divide this side by 2, it's just going to be x plus 1. Now I can go ahead and square both sides to get rid of this squared here, and I'll have 2x squared plus 2x equals x plus 1 times x plus 1. Well, that's going to be x squared plus x plus another x, which is plus 2x plus 1. Now I want to get everything on one side of the equation, so I'm going to subtract everything over here. I'm going to take 2x squared minus x squared is just x squared. And then 2x minus 2x, those two x's will cancel. If I subtract 1 from this side, it's x squared minus 1 equals 0. And I can actually then add 1 to both sides. So x squared equals 1. Take the square root of both sides, and so x equals plus or minus 1. And then I would want to check both of those to make sure that they do work, and they do. And so my solutions are that x equals plus or minus 1. That was a challenging one, but it's one that you guys can do. You're honor students. And so good luck with your homework assignment, and we'll see you tomorrow in class.